Good morning, everyone. I'm going to talk about my paper with the title Predicting User Preference with Neural Network Learning to Rank Method. This paper written by myself, my name is Nunung Nurul Komaria from Bina Nusantara University with my colleague Ahmad Nurul Fajar from Bina Nusantara University. So this is the outline I'm going to discuss today. Start with the background, related work, research method, result and analysis, and then conclusion and future work. Talking about the background, people nowadays can express their views and rating on some movies that have been watched. So for example, people can watch Inception, this is the movie, and then put the rating. And then we can see after people giving up the rating, we can see from the Rotten Tomatoes, for example, like this. Okay, so people rated 9 out of 10. And then there is summary that we can read in here. So before we pick which one we want to watch, we can search from this kind of website to see how good is this movie. In the current era, everyone can enjoy the explosive rise of web services informations. The attention rate of web users getting shorter and shorter every day. Everyone can switch screen and services in almost no time. Indubitably, a web page we can retain its users' retention a bit longer than the average is a real winner. One way to achieve this goal is by personalizing the web page content so that the users feel satisfied with what they need. So nowadays, the personalizations comes into play. According to Tendril and Valiamai, personalizations is the arrangement to the person with custom-fitted items, services, or informations. Companies have long offered personalizations in their websites based on the specific customer segments and with a direction toward users-oriented solutions. Consequently, the recommender system research area have also been shifting into personalizations in order to support the commercialization in the industry. Providing a personalized list of recommendation products to the users can be considered as a part of ranking problem. Many tasks in this domain involve ranking, such as document retrieval, collaborative filtering, keyword extraction, definition formulations, email routing, sentiment analysis, product rating, and spam filter. So what is actually a ranking problem? Ranking problem can actually associated with personalized tasks. Offering personalized items or services are typically presented in rank order of relevance. In this case, we can cast this learning of a rank order of relevance as ranking problem. The state-of-the-art approach of this research topic is called learning to rank. A general idea of solving the ranking problem by using learning to rank was first introduced by Norbert Fuhr in 1992. He described an approach in information retrieval as parameter estimation generalization. The first web search engine implemented this strategy is AltaVista, which later being acquired by Yahoo. They launched gradient boosting ranking function in 2003 and has been registered to US patent in 2003 too. It then followed by Microsoft Research Group, which launched RANKNET algorithm in 2005, which was used Bing search engine. This algorithm has been later improved, become LAMBDARANK and LAMBDAMARK. So when we talk about the learning to rank, so this is another domain area which they try to build a technique in supervised machine learning with the aim to train the model to solve a ranking task. As explained earlier, that this technique is originally designed to rank web search results. We explained the LTR in the original context, document retrieval. The case used here is when users submit search requests in a website or queries, and the user are shown with ranked list of search document. For example, the user wants to search for a car. He or she types the word car in the web search bar, and he or she will be presented with a list of documents which is sorted by its relevance to the keyword. This list of sorted documents is a result of LTR method. There are three most popular approaches in LTR. First is point-wise, second is pair-wise, the third is list-wise. So in the point-wise, basically every single document will be given an individual score, and then the rank is sorted by the highest score. With the pairwise model, every document will be compared with their pair, with its pair. So we take a pair of documents and then see which one is ranked higher than the other. And then the aim is to minimize inversion loss. So the swap, the incorrect order of a pair. However, the list-wise model. In the list-wise model, all the document, it can be seen as a list, a whole list. And then the aim is to minimize list-wise loss. In the learning to rank, the model represents a rankable item, for example, a document given some context. A user's issued query as a numerical factor. And then the ranking model F, mapping from X factor to real number, is trained to map the factor to a real valued score such that relevant items are scored higher. RANKNET. This is the first popular algorithm developed by Microsoft in 2005. It used pairwise loss functions. So the way that RANKNET work is by comparing between a pair of document and then sorted by which one is ranked higher than the other. With the lambda rank, it also proposed by Burgess in 2006, which is the improvement of RANKNET algorithm. It used list-wise approach. To train a model, we don't need the cost themselves, only the gradient of the cost with regard to model scores. It is desired that the gradient be bigger for pair of documents that produce a bigger impact in NDCG by swapping position. Multiply actual gradient with a change in NDCG by swapping the rank position of the two documents. So this is the illustrations. Illustration, the picture A is the picture when the NDCG equals to 1, which is the all got correct position in the rank. So the blue one represent the relevant document and the gray one represent the irrelevant document. So we aim to put the relevant document in the very highest level. In the picture B, we can see the NDCG is 0.790 because we can see that the blue line in the 10th row is far away from the correct places. So we got 1, 2, 3, 4, 5, 6, 7, 8, 8. 7, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 misplaced. Yeah. And then in the picture number C, the RANKNET gradient try to push the blue line further than the blue line in the number 3. But in the lambda rank gradient, they try to push this blue line in the 3rd row more farther away than the blue line in the 7. Yeah. So that's the main difference between the RANKNET and LAMBDARANK. So this is the illustration of the learning to rank with neural network. With the learning to rank, when we compare it with the classification algorithm, it looks like this. 5 ways to make $1 million without working. 10 reasons you should drink milk every morning. You won't believe number 71. Yeah, something like this. With the, this is 2 document. And then with the classifications, they just assign the click probability. Yeah. For document number A, with the document with the label A, is only 0.010. Document number B, with the label B, is only, the score is only 0.018. But with the learning to rank, I don't care anymore about the score. Yeah, what I care is about the rank. I want to know whether B can be ranked higher than document A, because document B is more relevant than document A, something like that. And then this learning to rank can be solved using the neural network. With the neural network, we have the input layer, and then we have several hidden layers, and then we can produce the output through the output layer. And we have some activation function in here. In this study, we use learning to rank neural network by YINXIAO Li, yeah, in 2019. She developed a Python library for training pairwise learning to rank neural network model. It supports pairwise learning to rank model, such as RANKNET and LAMBDARANK. The underlying model, hidden layer, is neural network. It implements Keras library, an open source library that provides a Python interface for artificial neural network. Keras acts as an interface for the TensorFlow library. The activation function can be softmax function, sigmoid function, Tanha function, ReLU, and linear functions. With the optimizer can be SGD, RMS-prop, ADAM, ADA Delta, ADAGRAD, ADAMAX, NEDAM, and FTRL. In our research, we use the datasets available in Kaggle. This is the dataset about the IMDb rating and metadata, which is the first dataset contain 5,043 movies released between 1916 and 2016. The data has 28 columns. And then the second data is data about the rating, which is contain the small set 100,000 rating from 700 users on 9,000 movies. And then from these 2 datasets, this is the first dataset and this is the second dataset. We combine this dataset together to get the rating and the movie data from the first datasets. With the pre-processing step, we first clean the dataset from any missing value. And then the second step is transform all the data into numerical type. For the cleaning step, we use imputation method by filling up the missing data with the most common value for each column. We also remove the user that has given rating for less than 20 movies, as it will not have enough data for the model to learn. After this cleaning step, we were left with 239 valid users and 25,345 valid entries in total. Other than that, we remove all the column which has unstructured text type, which would not useful for our learning process. For example, movie title, plot keywords, and movie IMDb link. This is the transformation that we perform we use label encoding for content rating label and for other categorical data. So we simply codify all the class in the categorical column into number 0 until 11, for example, for the content rating. So this is the data representation. After we merge both data sets, we come up with 27 columns in the data sets. And then we pick all 25 as the predictors, including number, critic for reviews, duration, director, Facebook likes, etc. And we pick only one label, which is the rating itself. And the query ID comes from the user ID. In the learning to rank, the rank is learned from each user query ID group. So we don't mix between this user with the other users. So this is why learning to rank is suitable for personalizations issues. In the learning algorithm, we use two types of implementations of learning to rank in neural net with neural network. First is RANKNET neural network with the hidden layer size 2 and 2 with the activation for each layer using the ReLU. And with the solver IDMAX, we differentiate between the epoch number 1 and 10. We try to increase the number of epoch, but there is no improvement zone, so we just pick these two. The second learning algorithm is LAMBDARANK neural network, which is short by LAMBDARANK NN. The hidden layer size is the same, 2 and 2, and then the activation function ReLU and ReLU, solver IDMAX. The number of epoch also the same, 1 and 10. As the evaluation technique, in our experiment, the dataset is divided into training and test data. We use holdout method with 70% of training and 30% of testing data. This is several evaluation metrics that we try to use to compare between those two approaches. First is normalized discounted cumulative gain. The second is root mean squared error. And then we also measure the Kendall, Stowe, and Spearman's rank correlations. And we also measure the speed performance. This is the example of the output from 10 epoch. First is for the RANKNET neural network, and the second one is for LAMBDARANK neural network. We can see in here clearly that the improvement is only happen from the first epoch to the second epoch. And then the rest is the same. The loss is not really improving. The same goes with LAMBDARANK. But if we can see the difference between the RANKNET and the LAMBDARANK, the loss that we have in the RANKNET is much bigger than the LAMBDARANK. In the second epoch, LAMBDARANK can jump from 262 to 0.002. This is very good. And this is the one epoch experiment result. We can see that the red one is for the LAMBDARANK. This is the NDCG graph for NDCG at 1 up to 10, the first 10 item. Yeah, when we rank and then we measure the NDCG, we can see clearly that LAMBDARANK is perform better than RANKNET. When we see, when we evaluate the whole output, yeah, we can see that in the first 1,000 item, the NDCG differs. But then the rest, we can see that it's quite similar. This is the 10 epoch experiment result. Again, we can see that LAMBDARANK is the winner. And we can see in the overall NDCG for the whole output, we can see that the first, for the whole batch of the output, the NDCG from the Lambda rank is higher than the NDCG from the RANKNET. And this is the other metrics. For RMSE, Kendall-Tau Spearman's rank, NDCG at 10, and execution time. We can see that the RANKNET perform faster, a little bit faster than Lambda rank, but it doesn't show any good result with regard to the NDCG and RMSE. Okay, comes to the conclusion and future work. In this paper, we presented the preference learning by using learning to rank with neural network for movie rating database. Our experiment shows that Lambda rank neural network work better than RANKNET neural network to learn this kind of data, even though it performs slightly slower. In the future, we plan to expand our work for different movie ratings datasets such as the ones from Rotten Tomatoes, Metacritic, and MovieLens. We can also analyze the reviews given by users to support the hypothesis. Okay, thank you very much for listening. Goodbye.